Hello, this is Mrs. Foy, and today we're going to learn how to calculate the mean absolute deviation for a set of data. Over the last few days, you've been calculating the mean, and now we'll take that one step further. I'm going to do a numerical example for you here. Um, the mean absolute deviation is the average of how much the numbers in a data set differ from the mean. So let's look at this example here. We've got these 6 numbers and we want to know how much they differ from the mean. So first of all, we need to know what their mean is. So you know how to do that. You add up your 6 numbers here, and I know they add up to 27. I divide it by 6 because there are 6 numbers, and I get a mean of 4.5. So how much do these numbers vary from the mean? Let's look. The numbers are listed here vertically in numerical order. They don't need to be in numerical order, but they are here. Then the mean is listed beside them. And now let's look at how much each of them differs from the mean. And so we see that there's 1, which is 3.5 below the mean, which is why there's a negative there. 3 is 1.5 below it. 4 is 0.5 below the mean of 4.5. 5 is above the mean, 0.5. 6 is 1.5 above the mean. And 8 is 3.5 above the mean. Then we get the absolute value of all of these differences. And you know absolute value is always positive. So the absolute value of negative 3.5 is 3.5. The absolute value of negative 1.5 is 1.5, and so on. Add up all of your absolute values. In this case, you get 11, and divide it by 6 for 6 numbers to get a mean absolute deviation of 1.83. So here's an example for you to work on. I'd like you to pause the video and you fill in this table. Make a copy of it in your math notebook and see if you can calculate the mean absolute deviation. If you need to, go back to the previous example. Welcome back. Let's look at your answer and see on your calculations and see if you set it up and calculate it correctly. So here the numbers are listed again in numerical order from 33 to 84. The mean is 60 and the differences are listed beside them. The absolute value of the distance is listed beside that, and all added up to be 84. Divided by 5 and you get 16.8. And the mean absolute deviation tells us if the data is close to the mean or if it's spread out.